Hello, calculus scholars. Today, we are going to be going over the power rule of taking derivatives, skill 13. And I really put you through the motions on the last skill with the limit definition of derivative. So today I'm going to be presenting a much easier way to take derivatives that work very well for most polynomial functions. So this is what's known as the power rule. So I like to kind of have this graphic here as the rules of deriving. Get it? Deriving, just like driving. I imagine that your car kind of felt like it was spinning out of control, when you were doing the definition of derivative, but now that there's the power rule, we have a nice lifeline for you. So just to kind of let you know here with the derivative, all of these things here mean derivative. So if you see these, we are referring to the derivative. And there's actually a whole battle of notation. So there's these feuding mathematicians, Newton and Leibniz, who both claim to discover calculus. And they actually had a battle over even the calculus notation. This notation here, you may actually kind of recognize it because maybe in science class you've seen change of y over change of x. So that's where the dy dx actually comes from. And we call this like f prime of x. This is the one that we kind of use the most frequently. So we say f prime of x. And of course, we could actually, as we'll kind of see in next class, substitute in x values into the derivative that we actually computed. All right, so in essence, the power rule has the same procedure over and over again. So what's going on is that you are going to be multiplying the coefficient by your exponent. So in this case, it would be n times x, and then you subtract your exponent by 1. Now, kind of a variation that you may see. Maybe there's a coefficient, ax to the n. And what you would do is you would do n times a, and then we would do the n minus 1 and subtract our exponent. So let's say that I have 4x cubed. So this is our f of x. And if we want to find the derivative of it, we do 12. And I'm just going to write the 3 minus 1. And if you are already good with this exponent rule, you could actually just go right to 12x squared. And that is your complete derivative. All right, let's look at some power rules here. On this one, we're going to take our coefficient times the exponent. So we get 21x to the 6th. And then here we have 5 times a minus 4. So we're going to get minus 20x to the 4th. 3 times 1/3, which is just 1. Exponent goes down by 1. 2x. And then the derivative of this is just going to be the constant And the reason is, so like if our f is 3x, and then our f prime would be 3x to the 1 minus 1, which is 3x to the 0, which is just 3 times 1. So just remember, x to the 0 is 1. And then the derivative of a constant. And actually would write a little note to yourself. The derivative of a constant is 0. Of course, I'd maybe package this a little bit more concisely. So I would write this as 21x to the 6th minus 20x to the 4th minus x squared plus 2x minus 3. All right, and then this one, and also kind of to make this grammatically correct, I write this as f prime of x equals to 21x to the 6th. Now in this one, I would write y prime, telling me that I took the derivative. This is going to be negative 6x, and I'm actually just going to write it out. And then remember, pi is a constant, so that part's going to be 0. So this is going to be negative 6, x to the negative 4th, plus 4x to the 0th, plus 0. And if it says on your delta map that they do not want negative exponents, you can just put that negative exponent downstairs to make it positive. And you would just have negative 6 over x to the 4th plus 4. Now on paper, I would also take negative 6x to the negative 4 plus 4 as well. But just pay attention to the directions on your delta map. And that, my friends, is the power rule. So today, or I guess in the next class, I'm going to have you just practice this power rule with straightforward polynomial functions to get you the confidence. And I'm even going to give you a little challenge on the delta math, where I'll start having you thinking about the tangent lines. And you can just try those out today. I'm only going to require, though, that you are doing the power rule. But next class, we will be thinking about how do we use those derivatives to find those tangent lines.